Welcome, everyone, to the Kubeadm deep dive. We got an agenda for you. So first off, we're going to go who these two people up on stage is. We're going to go over the mission of SIG Cluster Lifecycle, and more specifically of the Kubeadm project. We're going to go over our most recent achievement, getting Kubeadm past GA. And then we're going to talk about what's next. We've got a roadmap for 2019 with a bunch of cool new features that we're looking forward to. And most importantly for y'all, we want your help. Kubeadm is GA now, but that does not mean it's done. And we will have plenty of resources. A lot of these slides have links on them. And obviously, you can't click them on the projector, but the slides are available. And Tim and I will both probably be tweeting out links afterwards, so you can find those. So, who are we? This is Tim.
I'm Tim St. Clair. I'm now a senior staff engineer at VMware. I work on upstream. I've been involved in the upstream projects since the very beginning. If you want to have a long story of how I got involved from the very, very early days, I'd be happy to give you a tale there. And currently I co-lead SIG Cluster Lifecycle. I'm also on the steering committee, and I do a bunch of other stuff across the project too as well.
My name's Liz Frost. I'm a SIG Cluster Lifecycle contributor. I made KubeCuddle, the pony. There are still some stickers available if you want to come find them. And I work on Kubeadm as well as Cluster API for VMware ne Heptio. But we are not the only Kubeadm contributors. There are hundreds of contributors across several companies. This is a very wide-reaching effort across many companies. We've got VMware sort of Prime with Lubomir and Ross. We've got VMware ne Heptio with Tim, Liz, Jason, and Chuck is somewhere else. We've got
the SUSE folks, Merrick and Raphael. Some folks from Intel, Alex and Ed, they're around pretty regularly. There's a bunch of independent or have moved around to different companies. D, Fabrizio, Iago, he's a new reviewer. And of course, last but not least, definitely Lucas. He's been involved since the very beginning.
And we are on Slack. We've got a very large community of people just helping each other out in #Kubeadm. So what's the mission of Kubeadm? Why do we need it when there are so many other technologies whose roles seem kind of similar? So this is the mission statement straight out of our SIG Cluster Lifecycle Charter. We are going to simplify creation, configuration, upgrade, downgrade, and tear down of Kubernetes clusters and their components. Now, that sounds pretty broad, and we've got a slightly narrower mission for Kubeadm itself.
Yeah. So before I get into it, there's a lot of reasons why Kubeadm came to being. There's multiple motivations. There were a bunch of mistakes that were made. In the very beginning of the project, there were many installers, and like true sort of distributions in the very beginning, everyone had opinions, right? But what we saw is that there were common problems occurring across all the installers, and you were having a fragmentation problem. The purpose of Kubeadm was to distill down the common pattern into a reusable component that everyone can use. Right? This prevents the fragmentation problem from occurring and allows folks to move higher up the stack and deal with other more interesting sets of problems, and prevents like sort of a vendor festivus from occurring about wanting to be able to install the production grade version of Kubernetes. Right? But it's more to it than that, right? Anyone who knows me knows that I rant a lot about Unix philosophy, right? It's really important to how we designed Kubeadm to make sure that it only did a certain piece of the puzzle. What I think was probably the best feature of Kubeadm was basically stating that these are the non-goals, right? So when a lot of people look at Kubeadm and they want it to be all singing and all dancing, like it doesn't do my provisioning for me, like it was a question that came up earlier. And yes, that is on purpose. There are many tools to do those other different aspects or layers of solving the problem of what it means to stand up a cluster on a different provider of some kind. So by making sure that we adhere to a certain set of non-goals, Kubeadm maintains its focus on being the tool that allows you to stand up the MVP of a secure, reusable control plane for Kubernetes. So there's also a couple, like I mentioned before, that I talked about some of the key design principles there. We want to set up a best practice cluster. It's got to be simple. So one of the key motivations behind Kubeadm's original inception actually came back to DockerCon 2016 when Swarm was originally announced. When Swarm was originally announced, there was always this moniker that Kubeadm is complicated. It's very hard to use. It's very hard to get started. And then there sprung out a document started by Kelsey called Kubernetes the Hard Way. And I know a lot of folks in the audience who have done it their own follow the Kubernetes the Hard Way. I recommend you don't do that, right? A lot of effort, a lot of knowledge is baked into Kubeadm because we are right there at the source. We know when features are going in. We know how they get changed. We also make sure that we work with the other SIGs so that way when we're doing something, it's following the best practices. When there's CVEs that come up, we make sure that we mitigate those risks as quickly as possible. So, so that user experience dovetails into sort of not just the UX of the component of being able to ease the install, but also of reducing down the overall complexity of the state space of the problem to something that's far more manageable for folks who aren't deep inside the core of Kubernetes. Again, like I mentioned, the scope is bounded. We have a bunch of non-goals. I think the important piece here too is it's reusable, right? If folks want to do some opinionated pieces of it, you don't need to use all of Kubeadm. Kubeadm is broken into subparts, and we'll go through that later on, where you can use certain aspects of the tool, what we call phases. So that way you could actually build your own opinionated version of an install, because you might have to do something custom, by using certain aspects or pieces of the tool.
So this is our sort of component overview. I don't like this chart very much because it doesn't really make all that much sense to me. Load balancers do not run on top of Kubernetes. But for our purposes, this will do. The main purpose of Kubeadm is assume you have a bunch of nodes already. We don't know how you got them. We don't care. But you want to take those nodes and build those into a Kubernetes. Kubeadm is what takes it. If you consider this less of a architecture diagram and more of a flow chart with time going up, first you pick an infrastructure provider, then you get machines, then you use Kubeadm, and now you have a Kubernetes. So this is, I alluded to this earlier. This is our big achievement. In 1.13, Kubeadm is officially GA. What does that even mean?
So for those who are consumers of Kubeadm, I think the first and most important piece of the puzzle is that you have a stable command line you can rely on. Right? We're not going to shuffle around arguments. We're going to go through the full deprecation policy that's part of the Kubernetes policy that's written inside the community repository. So we are going to make sure that you can rely on it. We're not going to change things around. The implementation is rock solid stable. We test the heck out of Kubeadm, and we get feedback immediately, like almost immediately. As soon as something is released, there are users all over the world who are constantly giving us feedback. There is the general Kubernetes moniker, which I will hope to change in the future, and we'll try to help work with Release and other folks to make this become a reality. But the general moniker is that with Kubernetes is that you don't install a .0 release, you test a .0 release, right? But hopefully over time we will get to a more sort of dev and stable style of release cycle. So folks, when they get a .0 release, they'll feel comfortable being able to install and test and verify, and you'll hopefully over time you'll be able to have the same semantics. So it shouldn't change much when you're using Kubeadm. We upgrade between minor versions for every single release. That's part of what we've always done, but now you can rely on it for sure. We've been really conservative with our upgrade policy of how we do things inside of Kubeadm. So our beta cycle for Kubeadm lasted over a year. We wanted to make sure that we were doing things the right way. We wanted to make sure we had a clear path for support for the long-term growth.
So we have a configuration file. I'm going to talk about what that means in a little bit, but the configuration file schema is finally solid. And this I think is a big deal, not for individual users who might just be calling Kubeadm join, but for anybody who's building a cluster configuration tool. You now know that if you get your thing to work and you get the integration points right, you set up your configuration file, you will know that that is going to continue to work. You can rely on Kubeadm as a provider with the same API guarantees as the rest of Kubernetes. We're not going to change the way our configuration file works, remove keys that you're depending on in between minor versions, so you can continue to use Kubeadm with confidence. Kubeadm, the configuration is split into 3 parts. The motivation behind this is, who has ever looked at the number of flags you pass into a kubelet? There's a lot. And that's not just poor UX. It makes it very, very difficult to test. Now, I'm not going to pick on kubelet here, because when was the last time you actually needed to invoke kubelet by hand? That's configured automatically. Kubeadm init, on the other hand, that's a user-facing command. We expect that users are actually going to call Kubeadm init. And to make sure that we tested that as much as possible, rather than specifying every single command line option, we provide a configuration file syntax. The init configuration is only used when you create a cluster. You can see things in here like node registration. You can pass in extra args to the kubelet, because there's a lot of those. You can specify bootstrap tokens, which might not mean anything to you yet, but hopefully will by the end of the talk. You can set the node name. You can set taints on the node. Anything that you might need beyond the defaults that Kubeadm provides, we will provide you with the defaults, but if you need to do your own thing, you have the option to do that. We've also got a cluster configuration, which continues well past when you have set up the init configuration. That includes things like setting the image repository, fine-tuning cluster defaults, things like networking. You're going to need networking for the entire lifecycle of your cluster. You're going to need things like the API server for the entire lifecycle of your cluster. And custom arguments are very important, because these things are going to change, and the last thing you want is for your changes to be clobbered the next time Kubeadm runs an upgrade. So if you can persist your configuration changes in here, you can be assured that when you upgrade, those things will not get overwritten.
So more details on what GA means. Like I mentioned or alluded to earlier, is that it's a toolbox. So Kubeadm itself is a tool within the toolbox, but that tool has many different parts. It's almost like a Swiss Army knife, right? So as I mentioned before, we'll go into the next part of what actually phases exist inside of init. But there's also other aspects to here as well. If you want to use Kubeadm to stand up etcd and use it for etcd management, that exists inside of Kubeadm, right? So now you can have a securely configured etcd cluster using Kubeadm, following the instruction guides that are online. So what are the phases? Here's the list of the phases. And basically, it goes through pre-flight, kubelet start, certs, kubeconfig, control plane, etcd, upload config, mark control plane, bootstrap token, add-on. This took a long time to accomplish, to get the set of phases to be a canonical, non-overlapping set of features that allowed folks to invoke certain subsections of initialization routine that they wanted to. Now, if you want to, like I mentioned before, you can just depend upon this graph and you'd be okay, right? So if you want to use Kubeadm in its entirety, you can just use init. Otherwise, if you want to, you can just invoke individual phases about the things that you care about for your opinionated installation. This is super useful for a lot of folks who are in the wild, because they have constraints that not everybody else has, right? It's easy to do the simple story, but once you start breaking into sort of certain constraints that exist for like legacy providers, like if you're working in a company that has a lot of security constraints, like Liz will go into it later on, managing your certs is a really important thing, right? So this is basic flow. It's just top to bottom, flows all the way through of how init runs. So what you'll see in a standard init run is it will actually prefix what phase it is on the output of Kubeadm itself. So when it's running, it'll go through first beforehand and run a series of preflight checks. It'll verify that the software is installed correctly. You have some basic node configuration is there for allow Kubeadm to be able to install correctly. Then it starts the kubelet, right? So the way Kubeadm defaultly deploys a cluster is it uses static pod manifests to run the cluster in your environment. This basically means that the kubelet is looking at a well-defined location inside of /etc for these manifest files and then starting up the pods from those files. The next step is certificate generation, and Liz will go into more detail in there because there are a lot of options and knobs and bells and whistles there. Next is generate the kube configuration files, right? So this is what Liz was talking about a moment ago, where it's basically going to auto-generate, if you don't have them already, both the init and cluster configuration, right? That'll be the first part of init to be able to store that, to generate that with same defaults, then it uses those defaults. You can also specify the override via the command line. Next, like I mentioned, is the generation of static pod manifests. The configuration files, as well as the input argument flags, will then be sort of muxed together to make the manifest files that are stored on the machine, right? So you need to have the potential override for configuration knobs via command line arguments, as well as the configuration file, in order for you to create actual static pod manifests that won't change for the installation. Then, once those static pods are written to disk, the kubelet takes a little while to basically stand up those local pods. Next, after the control plane is actually up and running by default from init, it will then upload that configuration that we used, the cluster configuration, into the cluster itself in a config map. Next, it taints the control plane node. And then it generates a bootstrap token. That bootstrap token will be used later on for, as part of the join for other nodes that want to join the cluster. So that original bootstrap token, I think it's 24 hours by default that it kicks off. So if you need to generate more tokens, there are other command line tools that you can use, and Liz will go into that too, that help you to generate those tokens that you can use to join other nodes in case you wanted to join nodes over time, right? Then it sets up the RBAC rules, and last but not least, it installs the defaults, what we call the default core add-ons. That includes the kube proxy as well as core DNS. I will run through Kubeadm join a little bit faster. The reason why is because Kubeadm init has well-defined phases. And I'll talk about this later on inside of the roadmap, is that Kubeadm join does have well-defined phases, but the actual command line breakdown and the syntax for how we want to officially support that aspect of Kubeadm is not yet GA. We want to make sure that we break down init first, get all of those subcommands broken down so that they're easily reusable. Join has a lot less phases, but the reason why we're not done is you can see that there's a separate subsection which says experimental control plane. So part of doing HA deployments, we want the join semantics to be very, very simple. You can join a regular node, or you can join a node as a control plane. This allows it for a very easy use case of standing up HA clusters. Right.
Upgrading the control plane is a very important part of Kubeadm because it's probably one of the scariest things you can do as a cluster operator. Everything is running fine, and but all of a sudden you see, oh, there's a new release out, and you decide either it has some new feature you need, it has a security thing that you need. So now you have to take your perfectly happy running cluster, and you have to apply this upgrade and just hope for the best. We try to take as much of the guesswork out of that upgrade process as possible. So we run a whole bunch of pre-flight checks to make sure that this is going to work. We make sure your cluster is healthy because running an upgrade on an unhealthy cluster could have all kinds of weird side effects. And then we retrieve that configuration that we stored before. That means you don't need to remember where that file ended up. You don't have to make sure you provide the exact same one. That configuration is stored already. We retrieve it and make sure that we're upgrading in the exact same way that we init it. We have version skew policies, which means you can't go straight to 1.8 to 1.13. That would be very nice, but unfortunately, it's just not a very safe thing to do. And then we go through and we upgrade all of the individual pods. There's a whole bunch of pods associated with Kubernetes itself. This includes things like the API server, the controller manager, etcd if we're managing etcd for you. And then finally, we take those RBAC rules, especially important if there's a security update, and we apply those upgrades to RBAC and the upgrades to the add-ons. And now we get to talk about certificate management, which is very near and dear to my heart, because sometimes it feels like half of Kubernetes administration is just doing certificate management. So here we have a very, very pared down version of what a Kubernetes cluster looks like. You have probably seen diagrams similar to this a dozen times over the course of this thing, but I want to point specifically to those blue lines. Every single one of those blue lines represents a mutual TLS connection inside of a Kubernetes cluster. And where you see a mutual TLS connection, that means you are going to need, at minimum, 4 certificates to manage all the sides of that cluster. If you would like to set those all up yourself, you're welcome to. You would get to know OpenSSL command line probably more than you ever wanted to. But if you don't, we will do all of this for you. Kubeadm is not particularly concerned with user certificates, but we have all of these other certificates that we need to generate. And they have a hierarchy, too. They don't all, by default, go under just one hierarchy. So there's a root CA of CA for the proxy and a separate CA for etcd. So we make sure that all of these are signed by the appropriate authority to make sure that your cluster is as secure as possible. Now, here's what that looks like as a more diagrammatic thing, if you're more of a visual learner. And I'm going to walk you through a bunch of different ways that you can do this. Now, the simplest one is what we do by default. If you call Kubeadm init, you don't have any certificates whatsoever. This is what we're going to do. Every single light gray box is a certificate that we're going to create for you. And this is very straightforward. Humans are very bad at using SSL flags, but computers are fortunately very good at it. So we can just rely on them to set everything up properly. But that's not very interesting. What if you want to use an existing CA? If you want to work Kubeadm into an existing arrangement, you might already have a root CA. You might already have etcd. You might have all of these set up, and maybe they're already signed by a higher level CA. These are all things that Kubeadm supports. If you pass in a CA for all of these and a key, we will take that key and use it to generate those certificates. But maybe you don't want to have the key inside the cluster. That could be a major security risk. So instead, you can provide every single one of these yourself. This sounds pretty difficult. It could be something like, generate all of these yourself. But you could also already have a nice set of tooling that generates certificates for you, and you don't want us to touch it. If these certificates are in the places we expect, we will not touch them. We will just pick them up and use them. But the last case, and the one that's probably more like what you're going to encounter in the wild, is that it's some combination of the two of these. We had a user recently who wanted to make sure they had their own front proxy CA, but everything else they wanted us to generate for you. And you don't need to pass in any command lines to handle any of this sort of stuff. We will see if their certificates exist. We'll see if they are signed correctly. If we have the ability to issue one for you, we will. If we don't have the ability, we will let you know and error out so that you can recover. And basically, we do our best to make this honestly quite unpleasant task as enjoyable as it is possible for X509 to be. There's a bunch of other options too. We can, if you don't want to provide keys, but you also don't want to generate them all yourself, we will issue CSRs so that you can sign them using whatever cluster signing mechanism or certificate signing mechanism you have already. We will renew certificates. By default, Kubeadm certificates expire after about a year. Certainly, I don't know anybody whose cluster has gone down because they accidentally let that happen. And we can even use the cluster certificate API. Built into Kubernetes, it requires some configuration, but there is an API for getting certificates and issuing them and signing them. And we will let you hook into that if you want, just from the Kubeadm CLI. And now we're going to talk about what's coming next.
So as we mentioned before, this is kind of the contributor track. So when we talk about the roadmap, it's not just to pontificate. We really want help. We want user feedback. We need you to help make Kubeadm better. Just as Liz mentioned earlier, just because it's GA doesn't mean it's done by any far stretch of the imagination. So we have a current set of high priority things that we see now today of things that we want to do in 2019. Obviously, we want to get our current configuration level to V1. So the way semantics work inside of Kubernetes is usually alpha, beta, and then V1. Currently, it's at beta state, which means that you have certain guarantees inside the configuration file. We're not going to break things or be backwards compatible, or not backwards compatible. And getting to V1, it makes it even more stable for folks who want to sort of do templating or other things around the configuration files. Next, the most asked for feature is high availability. So we'll mention it later on, but we also have a survey out. So if folks wanted to, we'll give a link to as well. But we want to get your feedback on how HA is working for you. HA is very interesting. It comes with a lot of thorny sides that you have to deal with that you won't have to deal with in other scenarios. So we're not there yet. We're like 90% of the way there, but there's some opinionated ways of how we want to deal with certificate management that gets into a weird space, right? There's this balance between UX and security, and there's always like some give and take, some push and pull there. Continued promotion of alpha phases to subcommands. We still have a set of alpha phases like we've always had in Kubeadm before, and we'll promote some of those things into full-fledged subcommands or put them into the join phases. There's a broader effort. I don't know if Lucas is in the room right now, and I don't see him. There's a broader effort that's ongoing throughout the community that Lucas is starting. He's starting up a separate working group to address this, but I don't know how many people have actually looked at all the different ways you can configure components inside of Kubernetes and looked at all the command line flags. What you find is wide swaths of inconsistency. It grew organically, and now it's time for us, like we've done in SIG Cluster Lifecycle with other tools, is to take a step back, reduce the problem space, find the commonality, push into a core reusable component, and then from there we can then abstract up higher. So that way it could be something that could be even used by other people who want to build facilities that are Kubernetes-esque in the future. This is a lot of work, an incredible amount of work. So if you are interested and really care about version semantics as well as how to configure your components on your Kubernetes cluster, we will try to, feel free to come by afterwards and I'll try and hook you up with information with how to get involved inside the working group. Last but not least, there are aspects of other sub-projects that are being started, one of which is called etcd-adm, which is basically pulling out some of these portions that are inside of Kubeadm related to etcd management and making that its own reusable tool too as well, right? Right now it's currently, it's very much in the nascent phases, but ideally over time we can have a nice composable model for how we deal with management of certain aspects of the Kubernetes control plane. And one of the most important features or things we want to drive for in the next cycle is fixing some of the release and test and all the automation around it. So anyone who was there for the Contributor Summit talk realizes that We have our work cut out for us. It is not pretty how we actually do some of the release and testing for SIG cluster lifecycle artifacts, namely Kubeadm and some of the artifacts that are required in order for us to stand up a cluster. So what does that actually break down into? Some of the things that we want to do, and we've talked with other folks about this, is ideally in the future, in the hand-wavy future when everything's done, is that to have a much simplified PR blocking job. Right now, if you actually look at the set of PR blocking jobs that are related to standing up a cluster and provisioning a cluster to deploy the tests, it's a large swath of infrastructure, and that can flake out a lot. So the problem is not all those flakes have anything to do with the actual tests themselves. Some of them has to do with just straight up provisioning. Right? Kubernetes is a very large project. I'm sure Aaron can give stats on how many different tests are being run across different providers at any one moment in time. And it's a fantastic amount. So much of the flaking that we're actually seeing from our side has to do with provider stand-up and provider configuration. So if we can dedupe that and be able to push that into a much less run set of jobs, what we call periodics, we still get the signal out, but it won't be on a pure PR job, and we can do things much faster with an in sort of cluster environment that simulates or runs most of Kubeadm today. Next, we need help with release artifacts and how we publish release artifacts. Jeff and I were just talking a little while ago. I was also talking with Ben. We need help doing this. We want to be able to have everything that you build as part of KK is the same thing as everything as publishing a release in an ideal world. They should be no different. Right? They are different today. We want to fix that. Yeah. So if you're interested in this, there are a couple different efforts. They kind of span across SIGs and working groups. From SIG Cluster Lifecycle, we obviously have some high priority items that we need to address. But we also welcome folks to get involved in other efforts, right? So I see DIMS is here. So if you're involved in the K8's infra working group, let's help work together to try and make this better. So
here's our survey. If you use Kubeadm or you think you would like to, we want to hear from you. bit.ly/Kubeadm survey. We need your feedback. This is a tool that we make for the community. The basic goal behind Kubeadm is how can we make it easier to install and run Kubernetes? And we can't do that without your help. If you don't have time to contribute, this is probably the single most helpful thing for us that you can do. And if you do have time to contribute, well, we've got a lot of options for you as well. Our documentation is, I think it's pretty good, but it can always be much, much better. We're working on getting more contributors and reviewers because it's sort of the same 3 or 4 people. And we're all very friendly, and we would like to meet new people. We have office hours for various projects. That's a great place to drop in, learn what's going on, figure out what needs to be worked on. You can see all of our smiling faces. Cluster API has office hours if you're interested in that. Tim lied when he said we weren't going to talk about it. I talked about it right then, but that's all you get. There's a bunch of SIG meetings, links to minutes and recordings. You can watch us back at 2x speed, make our voices sound really funny, and just attend our Zoom meetings. They're all available, and you can just hang out with us on Slack. We've got really good emoji. Look for good first issue, help wanted, and SIG cluster lifecycle labeled issues in all of our repositories. And if you need help, we would be glad to have you, because we need your help. Couple links. These are the sort of things where you're probably going to need to download these slides. But we have a YouTube playlist. We have meeting notes. We have channels on the Kubernetes Slack. We have setup guides, reference docs, design docs, and you can read more about how you will get involved. So if you're watching this recording, hopefully right below it, there will be a link to the slides. And thank you all very much for coming.
So we wanted to allot some time for Q&A. I don't know how much time we're going to have left, so But if folks have questions, maybe we have a couple minutes right now. Right.
Hi, great talk. So just a question about certificate generation, if that's okay. Yeah, so let's say that we have a certificate from a third party, like DigiCert or something like that, and it's a wildcard cert, which are frowned upon these days. Would that be an acceptable root certificate for you to be able to set up all those mutual TLS connections between the internals of the cluster, or is it only more geared towards the front end?
It's a little bit more complicated than that because most of these components, they don't have domain names. So we expect, and the RBAC system expects, certain names for those certain components. It might work for, say, the API server. I think it is much less likely to work for, say, the etcd peer certificates. But I do not know. If that is something you need and it doesn't work right now, file a bug.
Great, thank you.
We got about maybe one or two more questions because I see folks filtering in.
How about downgrades? One of the riskiest things about upgrading is not knowing whether or not you have a path back, both from a node perspective as well as a control plane perspective.
So this is where the charter and Kubeadm will slightly differ. So the charter itself that we listed up was about the general availability of a certain feature called downgrades. That is currently only supported by much of what's the kubeadm scriptory that is legacy. In Kubeadm, we've explicitly stated that we do not want to support this type of methodology. We much prefer for you to do a backup and restore. There are many ways to do a backup and restore. There's Arc or there's many of etcd tools that exist for you to do snapshot and restore. We think that is a safer path because of the potential issues, especially in HA, of the ability to do downgrading because of how the internal semantics of how API versioning exists. I think other folks are filtering in, so I want to say thank you for coming. I hope you're having a good KubeCon, and I hope you have a great rest of your day.